What is WireGuard? WireGuard is a VPN protocol that provides a secure and efficient way to establish encrypted tunnels between devices. It is known for its streamlined codebase and focus on simplicity and performance. Overall, WireGuard is highly regarded for its efficiency and security, making it a strong choice for many use cases. Pros of WireGuard. Simplicity. WireGuard has a relatively small and clean codebase, making it easier to audit and maintain compared to other VPN protocols. Performance. It offers high performance and low latency, which can result in faster speeds and more efficient connections. Security. WireGuard uses state-of-the-art cryptography, and its simplicity reduces the potential for security vulnerabilities. It uses modern encryption algorithms like CHA-20 for confidentiality and Poly 1305 for data integrity. Ease of use. Configuration is straightforward and less complex compared to traditional VPN solutions. Cross-platform support. WireGuard is available on a wide range of platforms, including Linux, Windows, macOS, iOS, and Android. Battery efficiency. On mobile devices, WireGuard can be more battery efficient compared to other VPN protocols. Cons of WireGuard. Lack of built-in features. WireGuard is minimalistic and does not include advanced features like support for complex network setups or built-in VPN client features. Some of these need to be handled separately. Relatively new. Although it has been gaining traction, WireGuard is newer compared to established protocols like OpenVPN and IPsec, which means it might not be as battle-tested in all scenarios. IP management. WireGuard requires the management of static IP addresses for peers, which can be less flexible compared to dynamic IP setups. No built-in NAT traversal. WireGuard does not include built-in support for NAT traversal, which can be a challenge in certain network environments. Workarounds are available, but may add complexity. We're setting up the Office Mikrotik as a WireGuard server so that John, Andrew, and Mike can connect through it as peers. Let's configure the WireGuard on both the Office Mikrotik and John's Mikrotik, then check if we can access the Office PC server. First, you need to configure WireGuard interfaces on both sites to automatically generate the private and public keys. The command is the same for both routers. Peer configuration determines who can access the WireGuard interface and what type of traffic can be transmitted through it. To identify the remote peer, you must specify their public key along with the WireGuard interface you've created. Finally, you need to configure IP and routing settings to enable traffic to flow through the tunnel. Peer configuration determines who can access the WireGuard interface and what type of traffic can be transmitted through it. To identify the remote peer, you must specify their public key along with the WireGuard interface you've created. Don't forget to add the listen port to the peers as well. The endpoint is the public WAN IP, so on the Office Mikrotik WireGuard, you'll add John's WAN IP. In WireGuard, the allowed address is the IP of the WireGuard interface. To allow John's local IP address on the tunnel, you need to specify it in the allowed address. Click Apply, and you'll see that WireGuard comes with built-in configuration settings. Now, you need to do the same setup on John's Mikrotik WireGuard. Now, let's ping the office WireGuard IP from John's Mikrotik to see if it's reachable. Since we can ping the WireGuard IP, let's add a route on John's Mikrotik to access the office server IP. Now, we can access the office IP server through the WireGuard interface. Let's configure WireGuard on Andrew's and Mark's Mikrotiks.